In this video we're going to try to show you a few of the test procedures that are done on batteries and a few safety tips as we go along. Naturally, the first and primary concern when working with anything in the shop is your own safety and the safety of the equipment that you're working on. So of course we're going to wear safety glasses. Safety glasses are always required out in the shop at P-Tech, but especially when working around batteries because of the caustic fluids that are in the batteries, particularly sulfuric acid. You also may want to wear some rubber gloves. You also want to watch your clothes. If you're not careful with getting battery acid on your clothes, it may look fine at first, but after you wash them, you're going to see that you have lots of holes in them. Here's a typical pair of pants that has some holes rotted into them because someone left a battery sitting on a chair that they were working next to a boat they were working on, and then the owner of these pants sat on the chair sometime after. Everything looked fine at first, but after the first washing, these holes were found in the pants. Once you have the battery removed, the first thing to do is to clean the post. Take a wire brush and vigorously clean, particularly where the battery cable is going to be riding. Clean that, and we'll clean both of them so you get a nice shiny metallic surface shown there. Here you can see a nice shiny surface where we've wire brushed it. Once the terminals are cleaned, you want to take a shop rag and you want to wipe the surfaces of the battery down. If it's very dirty, whatever, you may want to blow it off with some compressed air first. Be careful not to be blowing that dirt anywhere where it may cause damage. Remember, it's going to have some battery acid on it. And we wipe it all down good and clean. If it's very wet, we may have to clean it with a baking soda or bicarbonate of soda mixture, as explained in the Understanding the Outboards motor book. Now that the battery is clean, we can go ahead and remove the caps and check the fluid in the battery. Okay. I'm going to carefully pry up on here, trying not to let any fluid splatter anywhere. And I'll usually flip my lids right over like that. And here again, I'm going to wipe off the surfaces here. Notice I'm being very careful to not let dirt get down into the cells. If you use a bicarbonate or baking soda mixture, another item you don't want getting down in the cells because it can neutralize the battery acid down inside of the cells. After you have wiped the battery down with the rag, you want to discard the rag in the proper container. You don't want it laying around where you might accidentally pick it up and wipe your hands clean, or wipe your face if you get a smudge on your face or something, because it's got battery acid on it and it's going to sting after a while. Got any little cuts, anything, sometimes just sensitive skin in general will get burnt by this battery acid. So you discard this immediately after you wipe the battery down in a proper receptacle. Now this motor has plenty of fluid. You can see the fluid is covering the plates. And it's right up to the collar underneath, so we don't need to add any fluid at this point. Also note, there are 6 cells in here. This is because it's a 12-volt battery. There's 2.1 volts per cell. So if I didn't know what type of battery this was or how many volts it was, I could easily just count my cells. I have 6 cells. That's 12. That would be considered a 12-volt battery, even though in reality it should be closer to 12.6 volts when it's fully charged. We still call it a 12-volt battery. Our next test is going to be the hydrometer test. Now this is a rather inexpensive hydrometer. It's not one of the real fancy ones, but we find it works just well here in the marine shop. What we're going to do is we're going to, using the ball, we're going to draw fluid up through the hose into the hydrometer. We want to make sure there's a little fill line right there, and we want to make sure our fluid is up to that level. So let's check our cylinders. We stick our hydrometer into the cell, and as I said, we squeeze that bulb and we let go, and it's going to draw the fluid up. And I did not get enough, so I have to try again. I really need to squeeze that and draw it up. Ah, there it is. Okay. Now I have the fluid right up to the level, and I just have to read my meter, and I want to hold it straight up and down, and I'm reading just under 1.250. Okay. Squeeze the bulb, let the fluid back in there, and remove it, and we can stick it into the next cell and continue on and take all 6 of our readings. After you take a reading with the hydrometer, you want to record each cell as you go along. Sometimes you get to cell number 6 and you forgot what was in cell number 1. So record each reading as you take that reading. If I find that my battery needs a charge, what I do now is, I don't want to put my caps on tightly. I'm just going to flip them over and lay them on. That will keep dirt and dust from going down into my cells. But it will leave me plenty of room for expansion of the gases as the battery heats up through the charging process. I'm then going to take my charger, and I'm going to attach my red alligator clip to my positive post and my black alligator clip to my negative post. Okay. I like to give them a little dig in, make sure that they got good contact. Next, I need to set my charger up. We don't want to put it on high or crank too often, because that can overheat the battery. We want to do it on a medium or low setting in most cases. And then we're going to set the timer if the battery has one. In this case, I'm going to go ahead and set it for 120 minutes. Then I'm going to go ahead and plug my charger in. When I plug my charger in, I should hear the charger come on, and I should have seen that meter come up a little bit. While the battery's charging, you want to check it every now and then. You don't want to leave the battery charged, especially on a high setting, overnight. If you want to leave it charging overnight, use a trickle charger, which is a small battery charger which only allows half an amp, maybe up to 2 amps going into the battery at any given moment. If we're putting 10 amps to it, we want to check it frequently with our hydrometer, making sure that we stop the charger once we get up to our 1.265. The next test we're going to do is a surface discharge test. Surface discharge is simply that. It looks for discharge across the top or sides of the battery. Basically what you have, if you have any dirt, water, or a crack across the top of the battery where voltage can leak from one post to eventually to the other post, or sometimes even to the top of one of the other cells, you will get a voltage reading with your meter. If you get this voltage reading, you want to go ahead and clean it, wipe it down with the baking soda real good, and try again. If you're still getting it, then you have a crack that you can't see with the naked eye, or even a track. A track is ingrained in the top, and voltage can travel across it easily. This has to be done with a clean, dry battery. So let's see how it's done. Set up our meter. I'm going to take a red lead that uses an alligator clip so I can attach it to the positive post. And my black lead I want with a probe so that I can I can drag it across there properly, and because I'm reading voltage, I'm going to go to the volts in the common terminals. Next, I'm going to set my meter for a low DC voltage reading. In this meter's case, I can do 2 volts. It has a 200 millivolts, but I'm not going to go that low. I'm not going to be that picky. I'm going to be looking for something in the 1/10 of a volt or more reading. Okay. As I said, my alligator clip I'm going to hook to my positive post. Now my black lead I'm going to run across the top while watching my meter. Okay. Now you're going to get an initial reading every now and then, so leave it right there and see if it stays up. If it goes away, that's just the weirdness of the digital meters, that they do that little thing every now and then. Okay, there I'm getting a reading of a 1/10 of a volt. I'm close to my cap, so I'm probably picking up a little bit of moisture there. Okay. So I would clean and dry this one more time. Once I got that 0.1 reading, I would clean and dry the top of the battery and try again until I was not getting any reading of significant value. A surface discharge will kill the battery even when there's no accessories on or anything like that. You may charge it all up, come back 3 or 4 days later, or sometimes even less time, and the battery will be dead. Now, before using the Ferret 42 HD or any shop equipment, you should familiarize yourself with the instructions. Okay? It can be found in this blue book in the battery cabinet near the battery testing station. Some shops will have a nice digital load tester like this. Okay? It's a nice roll around load tester. This is a Ferret 42 HD. It's a very precise instrument. It can also test things like your starting and charging systems for certain things. So that's why a lot of shops will have these laying around. Now the instructions will tell you that you need to take your red and your black leads and hook them up, red to positive and black to negative. Okay. Once you hook the leads up, you will see that the tester comes on. You see a digital readout of 12.41 volts. That's on the right hand side. Okay, and over here is the amps. Right now it's drawing that much, and we have to zero that out. To do that, we take the gray tester, we look for the arrow with the plus sign, and we hook that onto our lead with the arrow with the plus sign pointing towards the positive battery post. Now we hit the appropriate number, the minus or the plus. In this case we're going to have to hit minus to bring it down to 0. Okay, that's done. Now, because this was a 750 cold cranking amp battery, we're going to have to cut that 750 cold cranking amps in half and turn our load knob up to until we read 375 on our amp gauge. Okay. As we start to do that, the load on timer is the light's going to start flashing, and we're going to just try to hold it close to 375 as best we can until this becomes a solid beep. At that point we're going to read our voltage, and that's going to be our test results. So let's give it a shot here. I turn it clockwise. Again, you see it's hard to do. Kind of got to bounce it around there a little bit. Alright, we're 10.24 when that thing started to beep. Solid. With a test result of 10.24, that's well above our 9.6. We know because our shop temperature is well above 70 degrees. Anything above 70 degrees, 9.6 is the minimum voltage. In the winter time, if it got a little bit cooler, you may have to adjust for cooler electrolyte temperatures. Now this test was all fine and dandy, but as you could imagine, rolling that Ferret 42 HD out to a boat to test the boat's battery might be a little cumbersome, especially when you try to pick the thing up and jump from the dock onto the boat and carry it down into the cabin or whatever. That's why a lot of shops use a little handheld tester like this. It's not quite as accurate, but it does a fairly good job of telling us how our battery is. Okay. To use this tester, the first thing we want to do is set the 12 volt 6 volt switch on the right selection. Most of our batteries are going to be 12 volt batteries. Okay. Right. Secondly, we want to familiarize ourselves with the meter here. Of course, we have volts going across the top, and then we have this colored scale. Okay. If you look in this green scale, there's a series of numbers. Okay. We're going to take our cold cranking amp rating and we're going to try to judge where it is on that green scale where the green meets the yellow. And we don't want it to go into the yellow past where our number would be. For instance, we have 600 here as the second number from the bottom. Okay, if we had a 600 cold cranking amp battery, we would not want it to go past the green line right here into the yellow. Then it would mean weak. Of course, if it got down into the red on any battery, it would be a bad battery. If it goes into the yellow, then we would have to recharge it and test it again. If it fails to test more than twice, then the battery is bad. All right, once again, we're going to hook a red to red and black to black. As I hook up black, you're going to hear it beep. Okay, as you can see, I am reading 12.5 volts. So I'm pretty confident that this battery is ready to be tested. I've tested it with my hydrometer. It came up good. I've tested it with my now I've got 12.5 volts here, so I'm ready to test it. If it was less than 12 volts, then I would say, well, it's going to need to be charged before I even attempt to charge this. Then I'm going to hit the red button, and I don't have to hold it. It goes itself. But we're going to have to watch our meter, and then it's going to beep one time when it's done, and at that moment we have to catch and see what our voltage reading. So let's see what we get. Okay, see it's dropped down. And it's right at 11.5 volts, and then it beeped, and that's what our test is, 11.5 volts. Now, along with 11.5 volts, it was still in the green, around 800. This is a 750 cold cranking amp battery, so we're still good to go. So this battery has passed both of these load tests. Notice the one test came up with a slightly lower voltage. It put more of a load on it. But they both came up good, so this battery is fine to go. Okay, once again, red goes to positive, black goes to negative. So you can see we have over 12 volts freshly charged battery. we're going to hit the load tester button. Notice our voltage has dropped way down. We're still waiting the 8 seconds. Comes up, and right at that point we have just over 8 volts. Certainly a bad battery. Now, all of these tests are fine and dandy if the boat's in the shop for repair and you've got time to spare. What happens on Saturday morning when, Joe boat owner comes into your shop and he's, bought a battery from you at the beginning of the season or from someone else or whatever, and he comes to you and he says, hey, my battery's dead. I think it's a bad battery. Okay? It's Saturday morning. He doesn't want to go. He wants to go fishing. He doesn't want to sit around and wait for you to charge up his battery and test it. And all these tests, if you haven't noticed, need the battery to be fully charged, or they tell you if it's fully charged. Okay. This little baby here is called an impedance tester. This can test a battery that's down to 8 volts. Okay. And what it does is it basically checks the impedance, which is a form of resistance, but we can't use an ohm meter on a battery, of course, because ohm meter can't be used on a live circuit, and a battery is nothing more than one big live circuit. Right. What we're going to do with this is we're going to hook the red to positive and we're going to hook the black to negative. As soon as we've hooked the battery up, we see that it says 500. We need to adjust that. That's our cold cranking amp. So we need to adjust this up to 750. I hit these arrows down here until I get to 750. Okay? Then all I really need to do is hit the test button. Well, you'll see some lights flashing, and you'll see that it's saying that it's 12.34 volts. It's okay but low. In other words, it's saying it needs a little bit of a charge. Remember, a fully charged battery will be 12.6 volts. Okay, but impedance wise, it's saying it's okay. Now, if this battery were almost dead, let's say it was down to about 9 volts on the surface charge, this thing would still work but tell us it's okay and low. And we could tell the customer, well, something's wrong with your boat, it's drawing your battery down, but the battery's okay. That way he can make a decision on whether or not he wants to buy a battery because he wants to go fishing that bad, or he's going to wait a couple hours until the battery is fully charged. Okay. Either way, you're not the cause of his delay. All in all, it really doesn't take long to test a battery properly. We want to make sure when we're servicing our batteries, we keep our connections clean, we keep our batteries clean and dry. When we charge them, we don't want to charge them too quickly, and we don't want to overcharge them. Okay? We make sure that keep our waters full, and this is our job as technicians to make sure the batteries have a life as long as we possibly can, and that hopefully we'll catch the battery going bad before the customer finds out on the water and needs to be towed home. You will have a chance to perform all these tests yourselves, so you may want to review this video one more time before moving on to the next stage in your packet. Thank you.